to this edition of the Mathematics video series on perimeter, area, and volume. Each week we see buildings or gardens surrounded by fences where we can calculate the perimeter. Walk into rooms with carpet or tiles where we can calculate the area. And drink liquid out of a cup or container where we can compute the volume. Perimeter, area, and volume are so common in our life that we figure out measurements instinctively. Perimeter is the measurement of distance that surrounds a two-dimensional object. For example, it is well known that large supermarkets put items that you are most likely to purchase around the perimeter so that you must walk around the perimeter to see more of the merchandise and possibly buy more than you expected. Police put a security perimeter around an event to prevent harm to those inside. The word perimeter comes from the Greek word peri, meaning around, and meter, meaning measure. The circumference of a circle is the distance around a circle. The word circumference comes from the Latin word circumferential, meaning to carry around. Whether we are finding the perimeter of a polygon or the circumference of a circle, we employ formulas such as perimeter of a square, which is 4 times the length of a side because each side of a square is equal. The perimeter of a rectangle is 2 times the length plus 2 times the width because the opposite sides of the rectangle are equal. This is also true of a parallelogram as well. For a triangle, the perimeter is the sum of 3 sides. The circumference of a circle is 2 times pi times the radius, or since the diameter is 2 times the radius, then the circumference can also be given as pi times d. For any figure, though, you can compute the perimeter by adding the lengths of the sides. For example, in this trapezoid, you can see the perimeter. If we walk around the perimeter of a building, we might want to know how far we walked in order to estimate the amount of time it would take. For example, you come out of the Honda Center in Anaheim and want to find your car. After walking around the approximately rectangular building with a distinctively elliptical roof, you find your car. You walk 2 times the length and 2 times the width when you find out that you're back where you started. The field dimensions of the Honda Center are approximately 650,000 square feet, or approximately 60,000 meters square. This is the area. Area is given in square units. It is the measurement of a two-dimensional surface. Areas can be calculated using formulas by adding squares of 1 unit on each side as given in this figure, or dividing the figure into smaller common shapes with known formulas. You might want to know the area of a garden to know how many plants you need to buy, or the area of the walls in which you will purchase and install wallpaper. Some common formulas for area include the area of a square, which is side squared, the area of a rectangle, which is length times width, and the area of a triangle, which is 1/2 the base times the height. Actually, for a triangle, it doesn't matter what type of triangle you create. It's always 1/2 the base times the height. You can see that in this example. Take any parallelogram with base b and height h, and the area, base times height. In this figure, you can see that when you divide the parallelogram across the diagonal, that you make 2 triangles. You can think of the area of a figure as the sum of 30 separate squares. You can count all of the squares to get 30, or you can, using the area formula, multiply base times height. You can take the 5 units on the bottom times the 6 units in height in order to get 30. This is clear to see here, but using texture, shading, perspective, size, consistency, and depth cues, you can create a deceptive illusion of a size, depth, or distance. This concept is used with mirrors in homes to make the home look larger, or in paintings to make what is on a 2-dimensional piece of art look like an image that is very close or far away. It is also interesting to note that figures with the same perimeters can have different areas, and figures with the same area can have different perimeters. Volumes are also part of everyday life. We consume volumes of food each day. Although few people think about it, when they select a spherical orange in a grocery store, we compare not only the color and texture of the fruit, but the volume as well. The volume is a three-dimensional amount contained within a solid figure. Volume is measured in cubic units. Some three-dimensional objects are prism, pyramid, cone, and cylinder, and sphere. Notice that each of these figures is drawn on a flat surface, but they appear to have depth. Artists train in creating the illusion of depth and volume in their art, which allows us to visualize these better. Using curves and specially angled segments, we believe that we are viewing a three-dimensional object when, in fact, we are not. A prism is a solid geometric figure which have the same bases on the top and bottom, and they are parallel and the same size. While the most common prism is a rectangular prism, like a shoebox or a dresser or a textbook, prisms can have bases that are triangles, pentagons, or any other polygonal shape. The volume of a prism is the area of the base times the height. Understanding the concept of volume and substituting values into a formula are completely different. It is important for all people to be able to make comparisons. For example, which is larger, a yard of beer or a gallon of beer? Notice here that the yard glass is very tall, so it appears that it's larger, but it's not. Notice that the formula for the volume of a cylinder and the volume of a cone are similar, but they are not the same. Cones are pointed, and the volume is 1/3 the volume of a cylinder. The formula for a cone is 1/3 the base area times the height. However, if you watch a cylindrical cup of sand poured into a conical pile, you can see the comparison. Now, in this example, which container has more liquid? It might be interesting to note that children frequently believe that the taller container has the most. However, in this case, these all contain the same amount. On the other hand, it is interesting to note that the label on a cylindrical can of soup is rectangular. Notice that the base of the rectangle must wrap around to make a circle on the can. Whether we are opening a cylindrical can of soup, eating a conical ice cream cone, or playing with a spherical basketball, we see and use three-dimensional shapes every day. The concept of perimeter, area, and volume are found throughout our life. When you think about the ways you encounter these ideas, you will be surprised at how natural the ideas come to you. This is Dr. Rachel Winston signing off for this episode of the Mathematics video series.